Bismillahir Rahmanir Rahim. Assalamu alaikum, dear students. Today we are studying work, topic number 4.1 work. So, work can be defined as when a force is applied on a body and it covers displacement in the direction of force is called work. When the force is applied on a body and it covers displacement in the direction of force, that is called work. Okay. Or we can define the work in this way, that the dot product of force and displacement is called work. The dot product of force and displacement is called work. So mathematically we can write it as F dot D, where F is the force, D is displacement, and there is a dot product between them. If you remove the dot, you will place cos theta. So W is equal to FD cos theta. Okay. Suppose we have a box, we have a mass M. If we apply a force on the body and it covers displacement, so it means that we did some work on this block, on this mass. So if we apply the force, we will cover displacement in the direction of force, so that is called work is done. Suppose look at the gravity. This is the earth's surface. This is the mass. The force of gravity acted on this mass which is downward, and this mass will cover in the displacement downward, so this mass will move down. This is called work done by the gravity. So work means when the force is applied on a body and it covers some displacement, that is called work. So first we are discussing its unit. So for the derived quantity, you have to derive the unit from the equation. So look at here. The unit SI unit of work is joule, the SI unit of force is Newton, and displacement has unit of meter. So joule is equal to Newton meter. If we discuss CGS system, the unit of work is erg, the unit of force is dyne, and the unit of displacement is centimeter. So erg is equal to dyne into centimeter. Okay. Now remember, work depends on force, displacement, and theta. So there are three factors on which work done depends upon. Okay. If I am discussing the constant force, if I am discussing work done by constant force, work done, this is actually 4.1.1. okay, work done by constant force. So force is a vector quantity, and vector quantity consists of magnitude plus direction. Vector quantity consists of magnitude and direction. Okay. So if we talk about the magnitude and direction, if the magnitude of force and direction of force are constant, then the force will be constant. The force will be constant. So force is a vector quantity which will depend on magnitude as well as direction. Okay. So if we talk about the magnitude of force, so look at here the graph. This is the displacement, this is the force. Look at this graph. This graph is a straight line, and this straight line shows the constant force. The straight line shows the constant force. Now I am going to find the area. So look at the area under this graph. Look at the area. This area is a rectangle, and rectangle has a area, formula of area is length multiplied width. So length is actually displacement and width is force. So force in displacement is work done. So this is the work done. So area of FD graph gives the work done, and this work done is called the work done by the constant force, because the magnitude of force is constant. If the graph is moving up, it means the force is increasing. If the graph is moving down, it means the force is decreasing. But here the graph is moving straight line. It means the force is neither increase nor decrease. So here the force is constant. So this is the constant magnitude of force. Okay. So if we talk about the constant force mean its magnitude and direction both are constant. So suppose case number one, force is parallel to displacement. The direction is 0 degree, both are same in direction, and this 0 degree is not changing now. It is constant. This 0 degree is constant, it is not changing further. So suppose we have a body on which the force of gravity is acting down and it covers displacement down. So both are same in direction. So look at the work done. So work done is equal to F dot D, and if you remove the dot, you will place cos theta. And what is theta? Theta here is 0 degree and cos 0 is 1. So this work done is called work done by constant force, because the magnitude of force is constant and the direction of force is constant. So that is called the work done by constant force. Okay. Now this work done is called the positive work, or this work is called the maximum work. Okay. Now case number 2, look at case number 2. If force and displacement are anti-parallel means theta is 180 degree. Okay. If theta is 180 degree, suppose if the mass is moving up with the displacement d and the force of gravity is down. So look at here, the work done is equal to F dot D. If you remove the dot, you will place cos theta. And what is theta? Theta is actually 180 degree. And what is cos 180? Cos 180 is minus 1. So the work done will be negative work done. This work is actually the negative work. Now case number 3. Case number 3 say that force and displacement are perpendicular to one another. The force and displacement are perpendicular to one another. Suppose the mass is moving towards right and the force of gravity is acting down. So work done is equal to F dot D, and F dot D is equal to FD cos theta. And what is theta here? Theta here is 90 degree. And what is cos 90? Cos 90 is 0, so there will be no work done. So this is all about when the force has some magnitude and some direction, some specific constant direction. So this is the work done by constant force. Now I'm going to discuss the work done by variable force. So this is actually 4.1.2, work done by variable force. Work done by variable force. Okay. Variable force mean the magnitude of force and the direction of force is changing continuously. Okay. If the magnitude is changing or direction is changing, then the force is changing. So this is the variable force. Okay. Suppose if we apply a force of 10 Newton, 15 Newton, 12 Newton, 20 Newton, 30 Newton, look at the magnitude of force. The magnitude of force is changing. Suppose the angle is changing 10 degree, 20 degree, 30 degree, 40 degree, and so on. The direction is also changing. So the magnitude is also changing, the direction is also changing. So this is called the variable force. This is actually the variable force. Its example is, suppose if the mass is moving up from the earth's surface, it is moving away. So look at here, at each and every point the distance is changing. At each and every point the distance is changing. At each and every point the force is decreasing. But this force of gravity is decreasing as inverse square law. So it means that this gravitational force follows inverse square law. So it means that whenever the mass is moving up, so its distance is changing at each and every point. So its force is changing at each and every point. So it means that the magnitude of force is changing. If we talk about the satellite is moving around the earth. So at each point the direction of force is changing. At each point the direction of force is changing, the force is changing. If the force is changing, that force is called the variable force. Okay, suppose I'm going to discuss a body which of mass m, it is covering a displacement d1 and the force is actually f1, which makes an angle of theta 1 between one another. Okay, now for the work done, I have to resolve this force into its component. So I resolve this force into two components, Fy and Fx. So which component will do work? F1x, yeah, F1y. So the answer is F1x because it is in the direction of displacement. So work done will be equal to F1x dot d. This component will do some work while the work done by Fy is 0 because Fy and d1 are perpendicular to each other, so they will do no work. Okay, now look at here. If we change the direction, so this force is F2. Why the force is changing? Because the direction is changed. Now the angle is changed means the direction is changed, so the force is changed because in vector quantity, if the magnitude or direction is changed, the vector will be changed. Okay, now the another angle is theta 2, so we have to resolve this force again. So the vertical component of this force will not doing any work while the horizontal component will do some work. So it means that if any force changes the direction, its horizontal component is responsible for doing work done because the displacement is covering horizontally, so the horizontal component of force will do some work while the vertical component will have no work. Okay, suppose if the work done by f1x is f1 d1 cos theta 1, work done too by second force f2x d2 cos theta 2, work done by the third force is f3x d3 cos theta 3, means the theta is changing. If the theta is changing, so we have to resolve the forces into its component and their horizontal component will doing some work while the vertical component will have no work. So the last work done will be Wn, which is fnx dn cos theta n. Okay, now I want to find the total work done. So total work done will be equal to W1 plus W2 plus W3 up to Wn. Okay, so W1 is f1x d1 cos theta 1, W2 is f2x d2 cos theta 2 plus f3x d3 cos theta 3 up to fnx dn cos theta n. Okay, now take the summation of all these, so it will be fix dx cos theta di cos theta I, where I runs from 1 up to n. This is the total work done by variable force. So this topic is mathematical, not conceptual. Look at the graph of this force. So the graph of this force is actually is not a straight line. It is further increasing gradually, or it is decreasing gradually. So this is, if you want to find the area of this graph, so it will give the work done, but that work done will be the work done by the variable force. How we can find the area? So you have to divide this area into small pieces. When you divide this area into small pieces, so you can find the area of each piece and then sum of all the area of all the pieces, so you will get the total work done. So the area of this work done will be the work done by the variable force. Okay, this is all about the topic of work. So if you have any query, any confusion, so you can ask in comment section. I'll inshallah answer it. Okay, take care. Allah Hafiz.